Hello everyone, welcome back to my channel. Today we are going to talk about two fundamental searching algorithm. First one is linear search and then the second one is binary search. Binary search. Searching is very common operation in computer science. We try to find the position of an element in a given array. The efficiency of searching algorithm depends on how quickly we can locate the element, especially when working with a large data set. Okay, in this video we will be discovering how we can do that using linear search and then later by binary search. Now coming to linear search. Now whenever you look at the word linear search, we are going to search an element in a linear fashion. For example, let me consider an array 10, 20, 30, 40, 50. Now, let's imagine that I want to search 30. What I will do? First, I will consider this particular array and I will search 30 in this array. For that, I'll compare first element with 30. If it is not equal, then go to the second element, compare it with 30. If it is not equal, go to the third element, compare it with 30, and since both are equal, it is going to return index of the element, right? And you should know that the indexes in an array will start from 0, 1, 2, 3, 4. So in this particular case, you can see that will be returned with the value 2, saying that 30 is located located at index 2. Okay, this was a very simple way of explaining linear search. What we will do, we'll try and go and implement it. Okay, okay, let me create a new file, linear search linearsearch.c. You can see I have created a file, linearsearch.c. Now what we can do is we'll be implementing it using C program. So we are going to include standard library stdio.h. Okay, and then we are going to start in main. Okay, this is the main function that we are having. And if you want to search an element from array, it is compulsory that you should take a array, right? This is equal to, array will be declared in this way: 10, 20, 30, 40 and 50. And we'll finish the statement and then go to next. Int the key that you want to search. I'll consider int key is equal to, I'm going to search 30, so I'm going to take it as 30. And then we also require what is the length of this particular array. And to calculate length of particular array, we'll be solving it using the size of a array. Int n is equal to, this n is going to be our size of array. Okay, size of array. Okay, and divided by, you see I'm considering the size of array. If this is an integer array, it will be like 4 4 4 4. Total it will be 4 into 5, 20 bytes, divided by size of a single element, that is array 0. In this case array 0 is 10, so size of this particular 10, it is 4. So what it will do, it will calculate the size of array, it is 20, divided by size of the first element, that is 4, so value of n will be 5. Now what we do is will go for getting the result int result. Okay, here we'll be writing a function and I'll be calling that function as linear search. You can name the function as anything. It is not compulsory that you have to name it linear search only. In this linear search I'll be passing three parameters. One is array, and then the second one is n. N is the number of elements in the array, and then the third one is key. Okay, key means the element that is to be searched. Now what we do is we'll go and we'll write this particular function. You see, this function is going to return a integer value and that will be stored in result. So what we do, actually this is going to return the index of the element where it is located. In this case it will be returning 2. Got it? Now we go here, you will write the return type of a function, then linear. Let me copy this and paste it here, and then it will be receiving, this particular function will be receiving three parameters. Array, first one is array. You see the type of this is array, right? That's why I have declared it in that way. And then the second one is int n, and then third one is int key. int key int key. Okay, now we are going to write the logic of that particular function. You see, we wanted to search this particular element in this array. So what we need to do, we need to traverse from first element to the last element. For that we will require a for loop. For int I is equal to 0, means I am going to start with 0th element, and then I is less than what, you need to go till 0 1 2 3 4. In this case it is easy to identify the number, but whenever we have got larger arrays it is difficult to find the number. That's why we have calculated the size of an array or the number of elements in array. This n will tell us number of elements in array, and we are passing it in this function in the second position, and you can see we are receiving it here in the form of n. So we'll run a loop from 0 to n and I plus plus. In every step we are going to increment by 1. And then in the for loop, now imagine array of 0 is 10 and we need to compare this one. If it is equal, then we are going to return the index value. For comparing or for condition, we'll have to use if statement. In if, we will be comparing the first element initially with, if it is equal to key. Okay, if it is equal to key, then what we do, we will return I. Okay, now you see, in the first step, if array is equal to 0, then we will return array 0 is equal to key. It means if 10 is equal to 30, then we will return 0. Since it is not equal, that's why we'll come into, it will go back to the for loop again, increment. It will go on doing this. If it does not exist, what we will do, we'll return -1. You see, this particular function is returning an integer, and that's why it must return some integer, and in this case I will be returning -1. If this function is returning -1, it says that element not found. This is just a comment here, element not found. Okay, this has no effect on your program, and here this result will receive the output of that particular function. And now here we will analyze if result is not equal to -1. You see, if the function has returned -1, then we'll be able to understand that that particular element is not found in an array. But here printf element found at %d. Here I want to print the element. Let me take a /n here, and then you will print the result here. Got it? And then else, in the else statement, we will be writing element not found. Just copy it and paste it here. Element not found. Okay, got it. Now what we will do, we'll try to execute the function, execute the program, so that you will know what is the output of this. For executing, gcc and then the file name linear search. Okay, and -o and just name the output file output, or you can write whatever you want. And I click, you can see I got a output.exe. Now dot slash output, just click enter. You see it is giving a element not found, but we are actually having the element 30 in this one. You need to identify what is the actual problem. For that, what you can do, I'll show you how you can debug whatever the program that you have written. You see this is giving a wrong output. If you want, you can execute once again and check. Element not found, this is actually a problem. You see I have created an array, it is having 5 elements, and I am searching 30, but it says 30 does not exist. So what you can do is you can just check what are the values that we are passing. Now let me check. Printf %d, I'll be checking what is the value of n here. Okay, otherwise it will be difficult to debug. You can see that value of n is 5, we have got it here, so this is correct. And then next we have passed a array. Okay, now what we will do, we'll try to print every element. Printf %d /n and then comma array of the index. Okay, what it will do, it will just try to print and check, so that we will be clear whether the array is properly received in the function or not. Now you see what is the problem. You see every time it is printing 10. Okay, the reason behind this is we are checking the only first element, so it was giving an error. It should be I. You see now it is printing correctly, but it is saying element not found. It is because of this reason. We need to change the index every loop. That's why I'll be writing I here, and I got the error. Just remove it. This was a logical error that you may also face. You need to understand how you will debug these kind of problems. Okay, now you can see element found at 2. We are getting the right output. Now if I change it to 40 and just try to compile it and rerun, you will see element found at 0 1 2 3. Got it. Now this was the implementation of linear search, and now you will be seeing binary search, and but since it will take some time, now before going to the binary search, I will explain you one thing. There is something called as complexity. Here we'll be discussing about time complexity or space complexity, anything. Now let's imagine that we have got the element that is to be searched in the first place. Now imagine I want to search 10. Okay, if I want to search 10, I'll be getting it in only first step, right? So if element exists in the first place, then the complexity of this is big O of 1. Okay, complexity is big O of 1. You will learn what is the meaning of this in the class, but as of now you understand, if the best case of this particular problem is that whenever you are searching a key, it is found in the first place itself. That is the best case. So best case of this is big O of 1. And then worst case, in the worst case, you see if you want to search 50, you will be finding it after 5 comparisons, right? If you have got 100 element and the element is at the end, then you will be finding it after 100 element. If you have got n elements and you want to find a key and that is in the end, in that case you will be having the complexity as big O of n, because you need to make n comparisons to search the element. Got it? And the average case of this is also considered as big O of n. Okay, you learn all of this why we are writing this only. But as of now, I feel the linear search is clear to you, and we'll go for binary search in the next video. Okay, thank you.